Hello everyone, and welcome to this Ask Roberto episode. Today I will share some information about NDI format, compression, and interoperability. And at the end of the event there will be the Q&A session, so please prepare and submit your question. NDI is not only a video over IP technology, but must be considered a connectivity standard that allows systems to communicate, send and receive video, audio and data. And NDI use compression, which offers significant advantages. By efficiently compressing video and audio data, NDI enables the transmission of high-quality, low-latency video over standard network infrastructure, such as gigabit Ethernet. And a key benefit of this compression is that it allows multiple bidirectional streams to be shared simultaneously across a single network connection, facilitating a lot the complex live production setup and multi-source workflow. And NDI is codec agnostic. The concept that NDI is codec agnostic means that it is designed to support various types of video and audio codec. This flexibility allows NDI to adapt to a wide range of production needs and network conditions. So within this framework, NDI offers two distinct flavors, each designed to cater to different requirements in terms of bandwidth, quality, and specific application use cases. But let me share more information about the flavor. We have NDI High Bandwidth and NDI HX. And each of these flavors serve a specific purpose, allowing broadcaster, content creator, and AV professional to select the most appropriate version based on their particular need, whatever is maximizing video quality, conserving bandwidth, or focusing on high-quality audio distribution. So this diversity within the NDI ecosystem showcases versatility and adaptability to various production environments and requirements. Okay, let's start with NDI High Bandwidth. So it is based on the proprietary codec SpeedHQ, which is derived from MPEG-2. SpeedHQ is an iframe-only format designed to offer very high quality and low encoding latency. The SpeedHQ codec is highly optimized for CPU and FPGA and is the perfect solution for a software application and hardware devices. SpeedHQ supports the following color space, Chroma Subsampling, and bit depth: YUV420 8-bit, YUV422 8-bit, and YUV4224 8-bit with alpha channel. And if you have a encoder like this, this is most probably built around an FPGA. Now, NDI HX. This format was initially defined to allow PTZ camera to be part of the NDI ecosystem using their embedded video encoder, which is usually part of the system on chip, something called SoC, avoiding the need to develop a new hardware based on FPGA. Because FPGA is quite complex, build a new hardware product based on FPGA, the time to market usually is very long. And so with NDI HX, we do not provide any codec, but we allow compressed data pass-through, where manufacturer can use their codec, typically H.264 or H.265, and NDI as a transport protocol. NDI HX version 1 was only implemented by Newtek, specifically for camera from Panasonic, PTZ Optic, and Sony. And this was the NDI first release supporting a third-party codec, which at that time was H.264, which is a long-hop compression. And the supported color space is YUV with 420 Chroma Subsampling and 8-bit color depth. Version 1 of NDI HX required the use of a software application like TriCaster, vMix, or OBS Studios as a receiver, and the installation of a software driver to enable the software application to decode the stream. It has not been designed to be supported by hardware decoder. And currently, NDI HX1 continues to receive full support from software application. The codec is installed now with the free NDI tool, and it remains not compatible with hardware decoding. Now, NDI HX version 2 has been a big step forward in terms of quality, latency, and interoperability. The codec support has been extended to H.265, and the decoding capability has been directly added in the NDI SDK. So codec installation is no longer required. Moreover, we added support for the Discovery Server and NDI Group. The supported color space is YUV with 420 Chroma Subsampling and 8-bit color depth. So hardware manufacturers have had a certain amount of freedom in implementing NDI HX2. NDI has not defined precise specification, but suggestion, regarding the bitrate, the GOP size, and the streaming latency. The performance of HX2 camera and encoder really depend on the power of the hardware used. And with NDI HX3, we defined the format specification with detailed requirement about bitrate, GOP size, latency, and other aspects. And here are the detailed information about HX version 3. So the encoder supported can be, the codec supported can be H.264 or H.265. The color space is YUV 420 Chroma Subsampling and 8-bit color depth. And the formats supported are 1080 INP50, INP60, and Ultra HD P50 and P60. The GOP setting is 20, and the glass-to-glass camera latency, the camera to display, must be under 100 milliseconds. And the user cannot be free to modify bitrate, GOP, or change any other setting, because changing this will change this stream into a different format than NDI HX3. Moreover, NDI Discovery Server, NDI Group, and multicast support are mandatory in HX3. So, something I want to share about NDI HX and Alpha Channel. So officially, Alpha Channel is not supported by H.264 and H.265 codec. But by tweaking the frame size with NDI HX, we've been able to add Alpha Channel support. This support, anyway, is only available by software application like, for example, NDI Bridge. So NDI Bridge transcode from NDI High Bandwidth with Alpha Channel to NDI HX with Alpha Channel. And software application support HX with Alpha Channel. But hardware encoder and decoder do not support Alpha Channel with H.264 and H.265. Now, interoperability. This is an important topic that I like to clarify and share. So over the year, we ensure complete interoperability among NDI version, transmission protocol, and format. But full interoperability is not always feasible, given NDI support for multiple codec, primarily due to particular hardware implementation. So in the following slide, I'm showing the NDI interoperability matrix, and I start with NDI High Bandwidth. So as I said before, is based on the Speed HQ codec. And a software application or an FPGA-based hardware encoder can generate NDI High Bandwidth. And NDI High Bandwidth can be decoded by, again, an FPGA-based hardware decoder or by software application running on Windows, Mac, and Linux. Hardware codec, typically integrated on system on chip, cannot encode or decode NDI High Bandwidth. And then NDI HX1. So this format is generated by hardware encoder, typically integrated in PTZ camera or encoder. So, and thanks to a dedicated driver, software application running on Windows and Mac-based computer can decode it. FPGA, system-on-chip solution, and Linux-based computer do not support NDI HX1 decoding. Then, NDI HX2. This can be generated by hardware encoder, system on chip, or by software application. And it can be decoded by, again, hardware decoder and software application running on Windows, Mac, and Linux. FPGA is not the best choice for this kind of format. And HX3, well, this is basically exactly like HX2. Now, it's interesting to know that modern system on chip include both FPGA and H.264 and H.265 hardware codec. With this new generation of hardware, manufacturers are producing new products that simultaneously support NDI High Bandwidth and NDI HX. Now, what's new with NDI? NDI version 6 is coming with two big news in terms of quality increase: 10-bit color depth support and HDR. And this is the interoperability chart for NDI 6. As you can see with NDI 6, we offer the exact user experience of the previous version. Now, something to clarify. Thanks to the NDI SDK, every NDI 6 receiver will be able to support 10-bit HDR. But software application currently supporting 8-bit SDR will require significant upgrade to utilize this capability. Okay, I hope you enjoy this Ask Roberto episode. It's now time for the Q&A session. So, how can I help? And I receive already some interesting question. So the first one is, how does NDI address scalability in large-scale video production environment, and what measures are taken to ensure optical network performance when handling high volume of data? So NDI is really a pure networking. I mean, we support unicast and multicast, and but then this is really networking. I mean, is the network side that need to, being able to support this kind of big amount of data. That said, in our roadmap, we know that we need to improve, for example, multicast, and we need to improve even the discovery and registration, because, for example, I mean, the fact that the registration is done by a receiver, when you have a large amount of sender, I mean, sometimes this can be quite complex, to look for the right sender. Imagine that you have 1,000 sender, and this is happening, I mean, in the real life. We have a big user, big broadcaster with thousands of sender, and so there are ways today to limit the amount of sender you can discover in your network using, for example, properly NDI discovery server. But this is an area of improvement for NDI. So the second question is, can you elaborate NDI compatibility with various hardware and software solutions? So I think this has been already discussed during before. I showed the interoperability matrix. I mean, at the end, I answered to this question. Then, The other question is, given the importance of secure data transmission, what security measure does NDI incorporate to protect video stream and ensure the confidentiality and integrity of the transmitted content? So, in a local area network, we don't have encryption. We have something that can, that people and user can use to limit access to some stream using, for example, NDI group. But, sometimes encryption add complexity, and I mean, in a local area network, we don't think that at this stage is needed. Anyway, there is, we are considering encryption in our roadmap. But when we deal with internet, with NDI bridge, for example, this NDI bridge have a full encryption. So if we don't have any, let's say, security in a local area network, but we do support encryption over internet with NDI bridge. Okay, the other question is about latency, because latency is a critical factor in live video production. How does NDI address latency challenges, and what advancement of optimization have been made to minimize delays in real-time video streaming? So latency, yes, but since NDI is compressed, there is a limit below we cannot go. The compression takes some time, and so we cannot do anything against that. But there are many use cases where the small latency that NDI have is not an issue, and the few the few use cases where the latency should be zero, I mean, the user should look for a different solution like SDI or uncompressed technology. But again, you will, and many users experience that the latency in NDI is very low, and is not really a big issue in many different production or Pro AV use case. I mean, there are so many use cases where this small latency is not an issue. The other question is, in an ever-evolving industry, how does NDI plan to adopt to emerging technology and industry standard? Are there any upcoming development on enhancement the NDI protocol that user can anticipate? So in terms of protocol, I believe that with NDI 5, and the support of reliable UDP, which is coming from the QUIC protocol developed by Google, we reach a very big improvement in the transmission protocol. Because with QUIC, I mean, we can not only solve a lot of network congestion issue, and this is, by the way, part of the answer of the first question. Is really the big step forward we have done with NDI is supporting this new protocol. But then the advantage of this new protocol is that work over internet. So, and a very good application is NDI bridge, which, is using the QUIC protocol to send and receive, and let's say to interconnect NDI infrastructure over the internet. And this is thanks to the QUIC protocol. The other, news, as I told you before, NDI 6 is coming with increased quality, 10-bit color depth, and HDR support. And the other interesting news will be, for example, a bridge for embedded device. So there will camera, any hardware could be able to use embedded bridge. And so the camera, every equipment, even audio equipment, technically speaking, would be directly connected to internet using the NDI bridge technology. So I think I don't see other question coming, so maybe we can close this episode. So let me wait few seconds. No, so thank you for being here, and thank you for your attention to this Ask Roberto episode. And have fun.